Good morning everyone. Welcome to today's engineering mechanics class. I am Dr. K. Satyavivel. In this lecture, we are going to learn the fundamentals of engineering mechanics. This subject forms the foundation for all engineering disciplines because it helps us understand how forces act on bodies and how those bodies remain at rest or move condition. By the end of this lecture, you will understand the basic concept of engineering mechanics, its types, and the fundamental laws that govern the motions of object. Students, so let's begin our section. Before we start this topic, let us first understand the objectives of this course. The main aim of engineering mechanics is to develop the ability to analyze forces acting on different bodies. In this course, we will study static force analysis where bodies remains in equilibrium. Next, we will learn kinematics which deals with the motions of mechanics without considering the force causing this motion. Finally, we will study kinetics where we analyze motion along with the forces responsible for it. These concepts are essential for designing machines, automobiles, bridges, robots, and many other engineering systems. Now let us understand the meaning of engineering mechanics. Engineering mechanics is a branch of physical science that studies the behavior of bodies when forces or displacements act on them. In simple words, whenever we push, pull, lift, or rotate an object, engineering mechanics helps us understand how that object behaves. The main purpose of engineering mechanics is to predict the motion of objects and determine the effects produced by different forces. This subject is widely used in mechanical, civil, automobile, aerospace, and robotics engineering. So, engineering mechanics is mainly divided into two branches. The first branch is statics. Statics deals with the bodies that are either at rest or in a state of equilibrium. For example, a bridge carrying vehicle without moving is analyzed using statics. The second branch is dynamics. Dynamics studies bodies in motion. Dynamics is further divided into two parts. That is, the first is kinematics, which studies motion without considering the forces causing it. The second is kinetics, which studies motion along with the forces responsible for the motion. Engineering mechanics has many practical applications. Example, it is used in designing buildings and bridges, analyzing machines, improving vehicle stability, and developing robots and automated systems. So, we understand engineering mechanics clearly, we must know its fundamental laws. The most important laws are Newton's first law, Newton's second law, and Newton's third law, and also the law of gravitation and the law of parallelogram of forces. These laws explain why objects remain at rest, how they start moving, how forces interact with each other, and how multiple forces combine to produce a resultant force. Let us begin with Newton's first law, also called the law of inertia. It states that a body remains at rest or continues to move with uniform velocity in a straight line unless an external force acts on it. For example, when a parked car remains stationary until someone pushes it. Next is Newton's second law. It states that the rate of change of momentum is directly proportional to the applied force. This law is represented by the equation F Then next, Newton's third law. It states that for every action there is an equal and opposite reaction. For example, when we walk on the ground, we push the ground backward and the ground pushes us forward. These three laws form the foundation of engineering mechanics. Then now let us discuss two more important laws. That is, the first law is law of gravitation. It states that every particle attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. The second is the law of parallelogram of forces. When two forces act simultaneously on a body, they can represented by the adjacent sides of parallelogram. The diagonal of the parallelogram gives the resultant forces. This law is very useful in solving engineering problems involving multiple forces acting together. Okay. With this, we have completed today's introduction to engineering mechanics. In this lecture, we discussed the definition, types, application, and the fundamental law of mechanics. In the next class, we will begin with the concept of the free body diagram, which is one of the most important topics in engineering mechanics. Thank you for your attention. Have a great day.